In this last example, a certain fruit fly will double its population every week. There are originally 80 fruit flies, and the population continues to grow at the same rate. So in A, it asks how many insects are there after 5 weeks. So the number, n of t, represents the number after t weeks. So it starts with 80, and it's doubling every week. So we're multiplying that by 2 to the power of time, t being the number of weeks. So if we want to know how many insects there are after 5 weeks, we would fill 5 in place of time, 5 weeks. So we're evaluating 2 to the power of 5 here, and then multiplying it by 80. So let's bring out the calculator across here. So we would go 80 times 2 to the power of 5, which is 2,560. So that is the number after 5 weeks. In B, it asks at what rate are the insects increasing initially and then also after 5 weeks. There's 2 questions here. Now the rate, we need the derivative. So we're going to differentiate this function. So the derivative would be the original function 80 times 2 to the t, and then we multiply it by the ln of the base. So that's why this ln of 2 is in here. So that's the derivative function. Now, at what rate are the insects increasing initially? Initially means at time 0. So we'll put 0 in place of time. And so we'll evaluate that. So basically 2 to the power of 0 is 1, so it's really just 80 ln 2. And so 80 ln 2 would be 55.45. So to the nearest, and you can't have a part of an insect as something that's countable, so we would round that to the nearest whole number, which would be 55. So initially it's growing at a rate of 55 per week. We also want the rate at 5 weeks, so we'll put 5 in place of time. So here's our derivative, 80 times the ln of 2 to the 80 ln 2 times 2 to the power of 5. And so that's the calculation. So 1,774 is the rate it's growing per week. So initially it grows at 55 per week, and then after 5 weeks it's the rate's up to 1,774 per week. And that's the end of the tutorial.